Given f of x is equal to the square root of x and g of x is equal to 4x plus 2, find each of the following. Part A, f of g of x and its domain. F of g of x is equal to f of g of x. I'm going to take the function g and I'm going to plug that into the function f. This results in the square root of, we're going to take the 4x plus 2, we'll plug it into x. This results in the square root of 4x plus 2. So this is our function f of g of x. Now the part of the question we need now is the domain. The domain for this radical must be any non-negative value. So 4x plus 2 has to be greater than or equal to 0. Solving for x, I can subtract the 2 to both sides. 4x is greater than or equal to negative 2. And divide both sides by 4. X is greater than or equal to negative 1/2. So our domain is going to be from negative 1/2 to infinity. Part B, we're going to look for g of f of x. G of f of x represents g of f of x, which means I'm going to take the function f of x this time and plug it into the x of the g function. This results in 4 times the square root of x plus 2. We'll simplify this as 4 root x plus 2. Now if you look at the expression, it's defined everywhere except when the radical becomes negative. So we're going to make sure the radicand here is not negative. So we're going to set x being greater than or equal to 0. And this implies our domain is from 0 to infinity. Example 7, given that f of x equals 6 over x minus 3 and g of x equals 1 over x, find each of the following. Part A, f of g of x and its domain. We know that f of g of x, by definition, is f of g of x, which means I need to take the function g and plug that into the function f. So we'll take 1 over x and plug it into the x of f of x. This gives us 6 over 1 over x minus 3. Let's multiply the top by x and the bottom by x to simplify our expression. The numerator is now 6x, and for the denominator I'll distribute the x. X times 1 over x cancels out the x's, so we get a 1. And x times negative 3 is negative 3x. And this is our f of g of x. We'll start by looking at the domain now. To find the domain, we look at all the values that x can be and exclude values x cannot be. Looking at my work, I noticed that here there's a chance for the expression to be undefined. If x was 0, it would be undefined, so we need to exclude 0 as part of our domain. And continuing our work, we notice that here, if this was equal to 0, the 1 minus 3x was equal to 0, it would also be undefined. So we'll take 1 minus 3x and we'll exclude that from being equal to 0. Solving for x, I can subtract 1 to both sides. Negative 3x equals negative 1, or cannot be equal to negative 1. And we'll divide both sides by negative 3. So x cannot be 1/3. So we're excluding two values. We're excluding x cannot be equal to 0 and x cannot be equal to 1/3. if I plot these on a number line, we have 0 and 1/3 are open circles in our domain. So our domain is going to be from -infinity to 0, parentheses, union, another parentheses, 0 to 1/3, parentheses, and then union, 1/3 to infinity. So this is our domain. We're excluding 0 and 1/3 because 0 would cause our second step to be undefined and 1/3 would cause our last step to be undefined. So look through your steps, making sure at every moment you are not dividing by 0. Part B, we're going to do g of f of x this time. G of f of x means we're going to take the function f and plug that function into g. So we're taking 6 over x minus 3 and we're going to plug that into the function g. This gives us 1 divided by 6 over x minus 3. I can simplify this expression by multiplying the top and bottom by x minus 3. We'll multiply the top and bottom by x minus 3. And this gives us x minus 3 on the numerator, and the denominator is just 6. So here's our function g of f of x. To find its domain, again, we look at our steps, making sure that at every moment we're not dividing by 0. Only at one point do we have a potential division by 0, and that's when this expression, x minus 3, is equal to 0. So x minus 3 cannot be equal to 0, and x cannot be equal to 3. So we only have one exclusion, x cannot be equal to 3. So our domain is defined everywhere except at 3. So I'll just draw a little graph to show us our domain, and here is our domain. It's going to be from -infinity to 3 and union 3 to infinity. Example 8. Let f of x be equal to 4x plus 1 and g of x be equal to 2x squared plus 5x. Show that g of f of x is not equal to f of g of x. We'll start by looking at g of f of x. G of f of x means we're going to take the function f of x and we're going to plug it into g. So we'll take 4x plus 1 and we'll plug it into the x squared and into the x. This gives us 2 times 4x plus 1 squared plus 5 times 4x plus 1. We'll have to take 4x plus 1 and we'll FOIL that out. 4x plus 1 squared is equal to 4x plus 1 times 4x plus 1. 4x times 4x is 16x squared. 4x times 1 is 4x. 1 times 4x is 4x again. And 1 times 1 is 1. Simplifying this expression, we have 16x squared plus 8x plus 1. So we'll substitute this value in for 4x plus 1 squared. This is 2 times 16x squared plus 8x plus 1. And we'll distribute the 5 through the parentheses. That is 20x plus 5. We'll finally distribute the 2 to the 16x squared plus 8x plus 1. This is 32x squared plus 16x plus 2 plus 20x plus 5. Let's collect like terms. We have 32x squared. 16x plus 20x is 36x. 2 plus 5 is 7. So we have g of f of x equals 32x squared plus 36x plus 7. Now let's find f of g of x. F of g of x is equal to f of g of x, which means I'm going to take the function g, and this time we'll plug it into f. So 2x squared plus 5x is now going to substitute into the 4x plus 1. We have 4 times, we're going to plug in 2x squared plus 5x, and then add 1. Let's distribute the 4 to the parentheses. We have 8x squared plus 20x plus 1. And we cannot simplify that, so we're actually done. In conclusion, f of g of x is not equal to g of f of x. Example 9, find functions f and g such that f of g of x equals this expression. X squared minus 5 quantity cubed minus 4x times the quantity x squared minus 5 plus 3. I noticed that x squared minus 5 is repeated twice. So it looks like x squared minus 5 is plugged into this function f. So let's let g of x be equal to x squared minus 5, and we're going to undo the substitution. So if instead of x squared minus 5, we replace these by x's, we'll figure out what the original function f of x was. So this is going to be x cubed minus 4x plus 3. And in order to check my work out, I could always plug in g for the x's, and it does give us this original function back, f of g of x.